With everything is about d theta today. Okay, we are not finding slopes of tangents. Slope of the tangent would be dy dx. So we're not getting slope of tangent. We're getting something very different. We're getting d theta for polar graphs. And I want to let you know the way you can tell that this is not like vector valued functions is because we never take a derivative of a vector valued function with respect to theta, and number two, I don't have the little vector symbol above the r. So this is actually a polar graph, and I'm going to take the derivative of a polar graph with respect to theta, and we need to learn what that means. And what that means is, well, you'll find out soon enough. So let's go for it. I'm going to start with r. Oops. Oh, have we started? We got r of theta. I've got a polar function, and r of theta is going to equal 1 minus the sine of theta. Okay? Well, the first thing I'm going to do is graph this thing. And guess what? I'm sure not going to graph it by hand. Right? I'm not going to make a table of values and get all my r's. That's for suckers. I'm going to use my graphing calculator. So here we go. And if you have a graphing calculator with you, I'd like you to do the same. We're going to get a graph of this thing. Oops. Got my... Wait, what? Oh, I'm not even plugged in. That's so weird. Electricity never works if you're not plugged in. But it still doesn't work. What's going on here? Yeah. How can that be? Yeah, but it's gotta, the light's gotta turn on. I don't know. There is a separate switch. What a stupid design. Why would they have a separate switch for the light? That's absurd. I mean, who would ever turn on oh, whatever. Oh, that's weird. Did this thing break or something? Doesn't that look a little different? It looks smaller. Oh, it's got a brightness setting too. Interesting. Wow, it's just weird. I'm not used to seeing that rainbow. I'm not used to this being circular. Oh, wow, it's like messed up. I fixed it. I cleaned it recently, and I took it apart and put it back together. And I'll bet you that I messed it up. Here, just a second.
Just a little bit.
What the heck?
It was literally simple.
Yeah, the position of this big Fresnel lens must be messed up, and I look at that. It's supposed to be square.
Really? Put it like wrong side.
Yeah. Well, you can't really put a Fresnel lens. It doesn't matter whether it's right side up or upside down. But it's got a circular. It's circular now. That is so freaky.
Praise the sun.
What the heck?
Why is it so small?
I don't know.
Why is there a rainbow?
See, I don't know.
Well, because it's a prism, the glass.
I did something to it. I may have to go back to like my old overhead projector. I cannot look at this and figure out what I did wrong.
Why is like the front glass like looking down? Yeah, because the front glass looks weird. It's like a circle. Yeah,
I know I didn't say
you know, that's weird. And like, where do we like?
Yeah.
Circle. the front ones. Surface too low.
Oh well. Oh well, we can still live with it. It's just kind of freaky to me, that's all. All right, well, enough. Can you guys see that okay from where you are?
Yeah.
Right, back it up a little. God, how freaky. Okay. Well, hey guys, I need to go, first of all, go to mode, okay? And there's two things. Do you tell me, do you think in radians or do you think in degrees?
Degrees.
Well, I hope you, I mean, tell me, how big of an angle is 0.572 radians?
No idea.
I don't know. But how many degrees is 45 degrees? I know that.
Great.
So when you graph polar graphs, even though when you do calculus, you're going to have to be in radians mode, when you graph these suckers, you need to be in degrees mode. So I'm going to degrees mode right now. Okay? So here we go. Boop. I am now in degrees mode. Why? Because I don't think in radians. If I have an angle that's 1.4 radians, that means nothing to me. But if I have an angle that's 140 degrees, yeah, I got that. You see what I mean? So I want you to be in degrees mode, and then go down here. Do you see a function, parametric, polar, and then sequence? Go to polar, boop, okay. And so now, when I go to y equals, clear, I'm going to be doing that guy, and you'll notice it's r. This is r of theta, and so the right side you can only have thetas. Also, when you press the x button, now that you're in polar mode, if you press the x button, those are thetas. Alrighty. Now it's time to graph this. Okay. What angle do I want my theta to be between? What do you want the bounds of theta to be?
0 and 2 pi.
Good, 0 to 2 pi, except we're in degrees mode, so I'm going to go from 0 to 360 degrees. I think that's a good choice. Usually these guys tend to repeat every 360 degrees. Okay, so let's do something else. What's the biggest that my r, my radius, is ever going to be? No, not 1.
0.
Not 0. No, no.
2.
Yeah, 2, right? Because there are values of theta that make the sine of theta equal to -1. So the biggest that r can be is 2. So what's going to happen is once you determine that the maximum r is equal to 2, that's going to make your x min, x max, y min, and y max. Okay, you're just going to go -2 to 2, -2 to 2 on both of them. Your x min, x max, y min, y max are going to be plus and minus whatever your maximum r is, just so you're assured of getting that sucker on there, you know? So let's go for it. Press window if you have one of these old stock calculators. If you've got an N Aspire, I can't help you with a stupid Nspire. So I would say go from 0 to 360 on your theta. I'd say a step of 5 degrees is a good step. Don't have it be like 0.01 degrees because it'll take forever to graph. Don't have it be 20 degrees because you get something that looks like connect the dots. And then my x min, I'm going to go -2 to 2. Scale is going to be 1. Y min, -2. Y max to 2. Scale is 1. And now I'm ready to graph. Woohoo, here it comes.
I'm really hoping this works.
You guys should get something that looks like this. And when theta is equal to 0, okay, when theta is 0, my r is 1. So this right here is theta equals 0. This right here is theta equal 90 degrees. Over here is theta equal to 180 degrees. Down here is theta equal to 270 degrees. And then finally you get back to 360. Are you guys getting this graph?
Yes.
Because you're going to have this capability. Okay, now it's time for us to do the easy part. Here we go. Okay, dr d theta. Dr d theta is equal to the negative cosine of theta.
I'll be able to go. So
dr d theta, number one, the meaning. Someone tell me, what's the meaning of dr d theta? What does dr d theta mean?
no,
I'll give you a hint. It's the change of given a change of
change in R with respect to the
Yeah, you guys okay with that? Change in r with respect to theta. That's what dr d theta is. The change in r with respect to, or if you want to talk like a normal human being, you know, given a change in theta. Okay? So now I'm going to ask you a very simple question that's very hard to answer. And the simple question is this: is dr d theta positive, negative, or zero at certain points? Like, look at theta equals 0 and consider what r is doing as you pass through this point. Okay? Here, you know, theta would equal like negative 20 degrees as you come up here. So look what r is doing. Here's r. So my question to you is this: dr d theta, as my theta passes through 0, is my dr d theta positive or negative?
negative.
Zach says negative.
Yeah.
Does anyone agree with him? Okay, good for you guys. Carly, why do you agree with Zach?
Because the R is getting smaller.
Thank you, because r is getting smaller. You guys okay with that? At theta equals 0, and I'm going to write this in words, at theta equals 0, dr d theta is negative because r is getting smaller. Beautiful. Let me ask you another question. What's r appearing to do at 180? Here's my r. What do you suppose dr d theta at 180 degrees? What do you suppose dr d theta at 180 degrees is? How many people say positive? Yeah, because r is getting bigger. You guys okay with that? Okay, great. So that's the meaning of dr d theta. It's the rate of change of r with respect to theta. If r is getting smaller, dr d theta is negative. If r is getting bigger, dr d theta is positive. And so here's another question. What if dr d theta is 0? Like right here at 90 degrees, dr d theta ends up being 0. What does that mean?
No change.
What's that?
It's the min or max.
Thank you. It's a min or max. Let me write that down. If dr d theta equals 0, often, often, not all the time, but often, that means dr d theta, dr d theta goes from positive to negative. And if dr d theta is going from positive to negative, if you've got a situation where r is going from a position where it's increasing to a situation where it's now decreasing, what would we say is true about the r at a point where dr d theta goes from being positive, because it's increasing, to suddenly dr d theta goes negative? What does that tell me about the r right there?
Yeah, it's
Is it a min or a max?
always min.
dr d theta is getting, r is getting bigger and bigger, and then r starts getting smaller and smaller. So that's a max, correct? If dr d theta equals 0, often dr d theta goes from positive to negative, which means r is a relative max. Now, before I go on, Leilani, did you have a question?
Oh, AJ answered it.
Oh, good. But I don't have to give Andrew a part of my salary or anything. Okay? Tell me, what if dr d theta goes from negative to positive? Okay? Now what does that make r? That is, dr d theta goes from being a, here dr d theta is negative, and then here dr d theta is positive, because my r is getting smaller and smaller, then my r is 0, then my r starts getting bigger and bigger. What does that say about my r there? If r is getting smaller and smaller and then bigger and bigger. Hope you get that it's a min. Great. So, it is now time for us to do the math, okay? A, find critical points, and then B, find relative min, max of R using first derivative test. Here we go. I've got dr d theta equaling negative cosine theta. So what are my critical numbers for theta? What are the values of theta that make that dr d theta equal to 0?
Pi over 2.
Yeah, pi over 2 and 3 pi over 2, but I'm going to call it 90 degrees and 270 if you don't mind. 90 degrees and 270 degrees, yes.
It turned off.
What? Stupid graph. Okay, great. So you guys okay that that's my critical numbers? Okay? Now, I'm going to do first derivative test. Which means I'm going to go from 0 to 90 degrees, from 90 to 270 degrees. Again, I could be doing radians like what Fatima recommended, but I'm going to stay with degrees because, what the heck. Alrighty, these are the intervals of the theta. And then I'm going to get the sine of r, the radius. If I plug in a number between 0 and 90 degrees, my cosine is positive. If I plug in a number between 90 and 270, like if I plug in 180, then the cosine, wait, it's not positive. What am I thinking? There's a minus sign there. Oops. So plug in 45. Cosine 45 is rad 2 over 2, but there's a minus there. Then I plug in pi. Cosine of pi is negative 1, but a negative is a positive, or 180. And then finally, plug in a number between 270 and 360, like 300 degrees. The cosine of 300 degrees is positive, but there's a negative there, so it becomes negative. So I hope you see, at 90 degrees, do I have a relative min or a relative max? Yeah, relative min, just as always. Relative min at theta equal 90 degrees. And I can actually find what that is by sticking 90 degrees in here. R of theta would equal 0. R equals 1 minus the sine of 90 degrees, which is 0. And then finally, I've got a relative max at theta equal 270 degrees. And that's because the R of 270 degrees ends up equaling positive 2. Well, I'm going to have to figure out why this thing is messed up. God, that's so freaky. Yeah, when I took out that Fresnel lens, I messed it up. Okay, great. So let me do trace on this, and then I got to give you guys a problem to do. We've only got 5 minutes left, but these problems are pretty darn quick. Here's the thing. I am now going to press the trace button. But when I press trace, do you notice it has X and Y? I don't want X and Y. So I'm going to go second format. And do you see it? It says rectangular graphing coordinates versus polar graphing coordinates. You got to do second format. You need to be in polar graphing coordinates. So now when I do trace, it gives me R and theta. And I want you to see what happens as I trace. Do you see how the theta 5 degrees? And do you see how R is getting smaller and smaller as theta gets bigger and bigger? Okay, where R is getting smaller and smaller, theta is getting bigger and bigger. Maybe I can put this more in the center. Okay, until finally, when I get to 90 degrees, R is equal to 0. And now, as theta increases, R is increasing again. So I have a relative minimum at R equals 90 degrees. Because to the left of it, R is bigger than 0, and to the right of it, R is bigger than 0. Okay? So, and as I go, my R is getting bigger and, oops, I'm going the wrong way. So as I go, my R is getting bigger and bigger. R of 0.65, R of 1, I just passed through R equaling 1. R is still getting bigger and bigger until finally when I get down here, R is 2, and then R starts getting smaller and smaller again. So I found my relative maximum R. Okay. Well, it's time for you guys to do one. And all I'm asking you to do is find drd theta and find the minimum and maximum R and the theta values where it's located at. And so you're going to do that for the following equation. Here. And I guess I did dilly-dally too much, but R equals 1 plus cosine theta. Okay? Number 1, get drd theta. Number 2, get your critical numbers. That is those theta values. And then number 3, get min and max R's. Use first derivative test. Okay, good luck, you guys. If the bell rings, don't take off. This is so weird. Maybe it is in backwards. Somehow. Oops. Hey, are you guys getting a relative minimum at 180 degrees?
Yeah.
And here, let me graph, don't go yet. Let me just graph this really quick. This is now cosine. So here's what the graph of a cosine is. So all you've got is your R, you're starting here at 0, right? And then your R is getting bigger and bigger and bigger and bigger, okay? Until relative min, wait, from 0 to 180, wait,
One plus cosine theta.
what's going on here? Just a second, trace.
There's one plus cosine theta, you did one minus cosine theta.
Calculator.
Oh my God. Gee whiz. That's what I get for being the way I am. Okay, so you guys okay with that? That now, yeah, I start my trace and my R is at 2, and then I just keep going until my R gets smaller and smaller and smaller, then it minimums out at 0, and then it gets bigger and bigger and bigger. So between 0 and 360, I've got just that one relative minimum. So that's the sort of thing you're doing for those 4 problems. Thanks a lot.